everyone. Welcome to today's session. I'm Leah Hines, Executive Director of the Charleston Library Conference, and I'd like to welcome all of you to the future of scholarly communication in a ChatGPT world. Let me get started with my slides here this morning for our welcome. I'm just going to do a brief intro and turn things over to Gary Price. This is day 2 of our sessions. So if you were here yesterday, you got the full rundown of what Charleston in Between is and the history of the sessions. This session is being recorded and the video will be sent to all registered attendees. And we do ask that you complete a brief evaluation at the end of the session. We'll email it out to you. And your feedback is really important to us to help us to improve and to know what we're doing well. Feel free to use the attendee chat for comments, but please do use that Q&A button for questions to the panelists. And it helps us a lot if you would include the presenter name or the company name for any specific questions. General questions for the whole panel are great too. I'd like to say a thank you to our sponsors for the event, AIP Publishing, BMJ, and ProQuest TDM Studio. We'll have presentations from our sponsors this afternoon following our lunch break. And with that, I'm going to turn it over to Gary Price, who's moderating the AI Tools to Watch presentations. Thank you so much, Gary.
Thank you, Leah. Hello, everyone from just outside of Washington, D.C. in Silver Spring, Maryland. It's great to be with you again today. We've got a bunch of great panelists to share their resources with us and to learn from. Again, as Leah said, we welcome your questions by using the Q&A button. And we will get started. Our first speaker today is Juan Castro. So we'll get him up on the screen. And Juan is coming to us from the Netherlands, and he's going to talk to us about his company, Writefull. Juan?
Thanks, Gary. Let me share screen. Can you all see it?
Yes.
Good. Well, thanks, first of all, for having me. I'm Juan, one of the founders at Writefull. I'm also CEO. My background is mainly as a researcher, and I've been working in NLP for the last 20 years. And I wanted to talk to you today about, custom AI and in the world of publishing and education. So what's Writefull? So we've been around since 2016, and we provide services, language services and metadata services for publishers, institutions, and researchers. For publishers, we are all about making the process more efficient, both in terms of cost and time, and while making it still transparent and scalable. For institutions, we want to support authors and students, basically researchers and students, giving them tools and also giving teachers, for example, ways to track progress when it comes to writing skills. And researchers, we try to help them end-to-end in the writing process. So this is a simplified version of a pipeline, a publishing pipeline. So I'm going to walk you through different stages of this pipeline and services that we're offering. So all these services, we are working with publishers or copy editors. For example, for submission, we have a tool that is called Writefull Revise and allows authors to just upload the manuscript and get one back with language suggestions as track changes. So usually the publisher invites the author to use this service for free, so that they get a manuscript that is in better shape to go through the pipeline. And the same goes for structural checks. So we agree on structural checks with the publisher, and we check, for example, do all authors have an affiliation? Does the abstract maybe has a reference? So all these things help the publishers to not have to send back this manuscript to the author to fix these errors, basically less manual work. Triaging is one of the most important things here. Basically allows you to check what is the language quality of a manuscript. If the language is bad, usually takes longer to edit, it's more costly. So you can, these manuscripts, if you know, send them back to the author and ask them to proofread it. And also by knowing the quality, you can say to the vendors, okay, this manuscript is in very good shape, so it shouldn't take you very long to edit, so it should cost me less. So in batches how much it's going to cost you in advance. And something that we've added recently is that of detecting if parts of the manuscript or the whole manuscript have been generated using GPT. When it comes to copy editing, we also offer something that will automatically edit the manuscript, but it's worth saying here that it's just about grammar, so we're not changing the style or the content. And by doing this, we improve automatically the quality. So when you send it off to vendors, it will take less time and it will be basically cheaper. And as part of that, for the copy editors, whether they are in-house or offshore, we offer Writefull Revise so they can go straight where the errors are instead of having to check the whole manuscript, which makes the process more efficient. We also offer the manuscript categorization, which tends to be another model, and this is just for quality control. So how well have the copy editor checked this manuscript? So you make sure that the manuscript have a high quality when they go through the final stages of the pipeline. And the same for metadata. So does the author names are the same in the XML at the end? All these things that you need to check are automatically checked with Writefull. And the final step is that of quality assurance, whether you want to just make sure that it's not going to go through into production with some grammatical errors that shouldn't go. So I think the key part here is that why custom AI matters as opposed to generic AI, which are LLMs, is that most of Writefull has been developed in partnership with publishers. And because of these, all the models have been trained on academic corpus. We've also developed the ability to fine-tune on specific corpus like physics, biology, or anything in social sciences. And because of these two things, we get models that are very accurate and they are very aligned with the human categorization that was done by humans before. So for example, with ACS, we saw that the categorization accuracy or alignment was over 95%. And the mismatches were mainly about inconsistencies in human categorization. And the same goes for metadata extraction. We saw over 93% accuracy, and mainly the noise was coming from noise in the data. So the APIs that we have are plug and play, so you don't have to use all of them, you just can use a subset. And there we are always giving an evidence for the output. So we try to walk away from this black box of, this is a result, take it or leave it. And all the infrastructure is really built to scale. So we grow with the publishers. So everything is meant to, be able to cope with large amounts of manuscripts. So for authors, we have 3 products. Writefull Revise I talked to you about. Then we support Word and Overleaf. And Word is mainly, you check on demand the language quality, and you can also get track changes. And with Overleaf, everything happens in real time if you want. So the models are fast enough to support real time. We are also offering some widgets for authors. So this, for example, allows you to generate an abstract. It just takes the body of the manuscript, introduction all the way to conclusions, and generates an abstract. The same for generation of the title. Here we're using the abstract as an input. Academizer is something that allows you to write something very informal, some ideas, and it will translate them into actually something that you could use in an academic paper. And the paraphraser is just a widget that allows you to change the text with different levels, depending on how much you want the text change, but containing the same semantics. So here, what we get with institutions is that we have to address some of the issues that often you get with AI or LLMs in particular, which is AI and privacy. So what happens with my data? So from the very beginning, since we established Writefull, we knew that we were not going to store any texts, and we were not going to store language suggestions to improve the models. So that we addressed from the very beginning. Another issue that keeps coming back, something that institutions don't like much, is that they think that this AI will make students lazy. So for this, we are allowing institutions to disable the widgets if they want to, institution-wide. That this is also something that we've done. And we allow them also to see a dashboard per student where they can track how the user is, the author is improving. This is just a quick screenshot, and you can select dates and see per category, what type of errors the author user have seen, have made over this period of time in different categories, and also see basically the progress. So you see here, for example, that the grammar has been going down over this time. And also we offer institutions GPT detection, so they can input a text and they will see what is the probability that that text is coming from GPT in any of the flavors. And yeah, just to end, we also provide free trials to institutions so they can try all these services, and we can get this back and forth with them. Thank you.
Thank you, Juan. And again, questions for Juan, we will get to as many of them as possible, and for all of our speakers after we're done with all of our speakers. Next up is going to be Petr. Petr has joined us from the UK, and we're going to talk about Core and the soon to launch Core GPT. Petr, welcome.
Thank you very much. I'll try to just share my screen. Hopefully this will work well. And then I have got a presentation, and I'll just move it in the, I hope everyone can see my slide. Is this correct? Can you confirm correct? Yeah.
Yes.
Okay.
Yes.
Excellent. Excellent. Thank you very much. Okay. Thank you very much for inviting me. My name is Petr Knoth. I'm from the Open University, where I lead the Big Scientific Data and Text Analytics group. And our group focuses really on AI for open and responsible research. And we have a product as a group which is called Core, core.ac.uk. And I'll talk a little bit about Core at the beginning, and then I'll move to why I'm here, which is Core GPT. So what is Core? Core is basically a very large repository of open access content, which is effectively content collected from open access repositories worldwide, about 11,000 data providers. We have a mission to index all open access research worldwide and deliver sort of unrestricted access for all. I'm a data scientist by training and an NLP person. So when Core started, it really started from the perspective that we were interested in unleashing the power of text and data mining of research literature. And that has somehow driven us, but led us also to provide tools for others. So our group has a very strong sort of mission for open access. We are subscribers of the POSIT principles. We've got about 20 million monthly active users on the website at the moment, but what drives us is, and what has been driving us for a long time, is the ability to provide machine access to research. And in fact, some of the services that are being featured here in your presentations today and yesterday are effectively services or companies that we support with our data as well.
Hi, Petr. This is Leah. I'm going to interrupt for just a moment. I'm so sorry. There are a lot of comments in the chat about slides. So we see a browser window that says Core, what do you want to know today? And people are asking if they should be seeing slides.
Okay, that they should absolutely not be seeing that. Absolutely not. They should be sorry. They should be seeing slides. Yes, and so that is my
sorry about
complete failure. No. Thanks.
We could see a screen share, but I wasn't sure.
Yes, absolutely wrong. Thank you so much for this.
Yes, and thanks to everyone with the questions in the chat about it.
Yeah. So what I want to do is I wanted to share, in fact, not a window, but I wanted to share a screen. I wanted to share. How do I share a screen on this? I apologize for this. Okay, advanced. It doesn't allow me to. I'm not allowed to share a screen. Is that possible?
It says host and panelists can share.
I can share, but I can only share a window. I don't think I'm allowed to share a screen. Okay. All right. So I'll try this, and let me see if I do this, and if I move it to, no, what can you see now?
I see our services on the left and a small slide on the right with a plus sign in the center.
Okay, that's not correct either. Okay, that's
someone said go to presentation mode and then share that.
Problem
let's see
is,
here.
I don't see the ability to, I don't have the ability to share a whole screen so that I could go to, I just don't have it here. I'm really sorry. Share screen. I can only select Windows, but I cannot select the whole screen. For some reason.
Go, full presentation. And
I can't hear.
one of the options will be that.
Okay, I will need to. Okay, I'll do something in between. Okay, I do apologize for this. This is not planned. I'll try to share it with you like this, and I'm really sorry. I'll try to do. It's not great. I know it's not what I intended, and then maybe there is an ability to swap it. Swap displays. Can you now see the whole screen, please?
Yes.
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 Okay. All right.
Try
perfect.
switching
Okay,
slides.
so
There it
is-
goes. There it
Yeah,
goes.
yeah.
Perfect.
Okay.
Yay.
So this is what I was talking about. I apologize for this disaster. Okay. So yeah, I was talking about core. Our focus is on indexing all open access research worldwide and on effectively providing seamless access to machine readable content from open access repositories. We provide services for content discovery, search across open access repositories, recommender system across open access repositories. For instance, our system is embedded in about 500 library systems across the world, including, for instance, archive.org, a discovery system, then several services through which various kinds of clients, whether commercial or academic, can have the ability to access research literature via an API dataset or a system we call FastSync. And then we provide also some management services, such as the repository dashboard and our OAI resolver. Core is really being used in many different use cases. They range from plagiarism detection to fact-checking to drug discovery, market prediction. And this is, in fact, something that we intended to do right from the start. We realized that we cannot solve all the problems, and we just wanted to make it easier for a lot of companies that want to utilize AI and want to start sort of doing data mining to be able to get started quicker, basically, and not have the sort of difficulty in always having to provide harmonized access to research literature. So our sort of income stream comes from both commercial partners, and some of them are listed here, and also we are becoming a membership organization now. So we work a lot with higher educational institutions who have the ability to become our members, basically, and support us. And this is why I'm sort of here today. Very recently we introduced something we call Core GPT. This is a combination of Core and GPT. This comes from our basic enthusiasm into the new language models, which are providing lots of new opportunities in this space. So what we have created, and what I don't think because of the slide sharing I will be able to show you today to the extent I wanted to, is that we created this GPT search engine. This is a question answering system which tries to address the issue of retrieving something, of reducing the biases, basically, that we get from GPT. GPT is trained on everything on the web, and basically we sometimes want answers which are more sort of evidence-based. So what you can do is that you can ask GPT for results, and of course this, I will see if this video can show, but it won't. Okay, it won't show on the slide in the way it was supposed to. But effectively, I am asking GPT a question: what are the latest research trends in biomimicry? And GPT will then give me an answer like this, which basically is an answer not just generated by GPT, but in fact supported by evidence and references from within scientific literature. So we're effectively asking GPT to compose the answer using content from within open access literature. And why is this particularly interesting? So this is interesting because of several sort of reasons and reflections. So these models in general are very powerful in synthesizing content and creating summaries from lots of different places. They can be used to compare and contrast. They are really good at this, but sometimes they can get also confused. ChatGPT, the key unique selling proposition of effectively core GPT is that all the answers need to be anchored to something that it finds in research papers. That makes the answers a little bit more honest, and it sort of, GPT is well known to provide various kinds of hallucinations. Sometimes when it doesn't know the answer, it can start inventing basically some sort of answer which is completely fabricated. And so we have found that the core GPT is a little bit less prone to this sort of hallucination. It tends to tell you more, I don't have enough content to provide an answer, or I'm not sure based on the data that you provided me, which we think is a positive thing in certain kinds of situations. And also, I think, and perhaps most importantly, anchoring content with the answers with references make it somehow easier to assess trustworthiness of the answers. So, sometimes I think that one of the biggest dangers of GPT is that it can be made to argue your way, basically. So if you ask it to do something to argue why something should be done in this way or that way, it can do it in a rather persuasive way, where basically an unsuspecting reader, might not realize that they are being misled. And so I think having to sort of provide references makes it easier to find out if GPT is not doing well, that maybe something is getting wrong. And I think that improves the reading ability. So in terms of take home, first of all, I do apologize for everything at the beginning of the presentation and for telling me. But what I would like you to remember is perhaps that core provides a really large corpus of open research papers which can be utilized to make GPT answer in an evidence-based manner, basically. And what we are trying to do with core GPT is that we are trying to now put it in the core API so that it not just for the purposes of someone wanting to use that model, but maybe for other systems wanting to use this and feed the results into their own services. Overall, our group is very interested in working with everyone else on research projects in the area of AI for open and responsible research. So that's sort of part of our mission. So that's all from me for now. Thank you.
Thank you, Petr, for your presentation. And we will move right along. We will now head to Krakow, Poland, and speak with Artur from Laser.ai. Artur, welcome.
Hello, everybody. I hope you can hear me well and see my slides as well. So it's my pleasure to present to you on our tool called Laser.ai, and especially where it positions itself in a ChatGPT world. Evidence Prime, the company that develops Laser, is a spin-off of McMaster University. We are a team of more than 25 people. Working in the field of evidence-based medicine. So basically our mission is to build the best possible tools to support evidence-based healthcare. And this is not only Laser, but we also have a quite popular tool called GradePro, which is used for guideline development. So many of the guidelines that may impact you on a daily basis may also be developed using our tools. So I guess many of you in the audience know very well what systematic reviews are, given your background in information science. But to just get everybody on the same page, systematic reviews are not simple searches for studies. They are very well-defined processes for capturing all the relevant evidence that we have on a given health question. So the graphic that I have here on my slide, I think is a very good reflection of what happens in this process where you start with a big number of references and then you try to distill them into some knowledge that you extract from the papers into some more structured format. So the big, I would say, difference when you compare a systematic review against a typical search is that we deal with thousands of search results, and very often we end up with hundreds of included studies. So it's not sufficient to just go through the first page of results. Very often our users need to manually review thousands of studies. And what is also very important here is that very often this all is very context specific. So we may find studies that answer our question directly, but very often there are so-called indirect studies or indirect evidence that we need to retrieve. And here we need to extract some information from the studies that is, let's say, very often hidden between the lines. So just to give you one example of, a simple example of when it happens, is that if your particular review concerns hospitalized patients with COVID-19, you are not really interested in extracting the total number of patients that were in a given study, but you also want to apply this additional criteria that you have, that you want people that are hospitalized, that have confirmed COVID-19. And this very often is tricky. As you can see in my second example here, it's often the case that you need to perform some calculations to really get the end result. Here you have a screenshot of our user interface to also showcase the level of detail that our users need to extract from these studies. So as you can see, they pretty much need to capture things like what is the exact statistic, what is the variance. And of course, this happens for many PDFs, for many studies, and for many data points. We have some research that compares our AI enhanced user interface with the traditional way of conducting systematic reviews, where, for instance, for data extraction, we I don't want to use the word replace, but we used suggestions from the machine that are then reviewed by a single human reviewer, as opposed to the traditional way of having two people working one after the other. And the results that are from our, let's say, previous generation of models were already very encouraging. So we were able to achieve a very comparable level of quality while saving around 50% of effort. So kind of circling back to the main topic of this conference, we spent really a considerable amount of time training our own models, building these tools. And now, whether the rise of the generative AI, ChatGPT, GPT-4, whether it all makes a tool like us obsolete. So I would argue that it's not, and many of our unique features still hold. So things like the ergonomic interface, customer support, flexibility, and so on. And more, let's say, and kind of listing 4 areas where I think that tools like ours will still be needed, is that if you use something like ChatGPT, you need to kind of make, you need to test it first, right? You need to validate how well it does the job. So I would argue that it's better to delegate this task to a company like ours, where we have validation data sets and we have experience with validating models. And we can also choose really the best models for the job, because GPT is perhaps not the best architecture to solve all the tasks that we solve. There are also other architectures, other very important and useful models, and we position ourselves as experts both in evidence-based medicine and in AI, so we can make some, let's say, good suggestions here. So secondly, something that I think was already brought up here, we do fine-tuning to the biomedical domain. We also understand what data needs to be extracted and how this data should be extracted, because it's not always clear what these different fields really mean and what are the best practices for populating these fields. So we also think that from now on, really the value will be delivered in the user interface, how the AI is integrated into your workflows, and also security and compliance. This is something that we spend a lot of time on. We hold a number of certificates in this area to give our clients the peace of mind that the studies that they upload are not shared with the world or with potentially some companies that use this data to train their models, but that we can actually trace where all this data goes. Thank you very much. Thank you very much, and I hope that we'll have a chance to answer some of your questions during the Q&A part.
Thank you, Artur. And next up, we will head to Eric and Christian from Consensus. Wait a minute, yes. The guys, hello, gentlemen. I believe you're speaking to us from Boston, Massachusetts today.
That is correct.
We are.
And we will let you go and share your presentation with everybody. Thanks.
Fantastic. Thank you so much, Gary. Yeah, we are calling live in from Boston at luxurious Consensus headquarters, which is just Christian's living room. Very efficient. But thank you so much for having us, Gary, and great job to all of the presenters who came before us.
Yeah, super cool.
So yeah, in Consensus ethos, we'll try to keep it short and simple. I'm going to give a quick overview of what Consensus is, who it's for, what makes it a little bit different, and then we'll have Christian do a quick demo. And then we'll be excited to answer any questions we have in the Q&A panel afterwards. So at a super high level, what is Consensus? Consensus is a search engine that uses artificial intelligence to search for and surface claims made in research papers. There is a lot of different ways you can execute a search, but it really is designed to take in a natural language research question as the input, and then what you are returned are word-for-word snippets that we have trained our algorithms to go through papers and find. We've defined these as claims, which are assertions based on the evidence of the experiment. We hired a team of about 20 PhDs to hand annotate a bunch of research papers, feed those to models, train how to look for those within research papers. The database that we're currently searching over is the Semantic Scholar database with about 200 million papers across domains. As Petr mentioned, we also have a partnership with Core. Unfortunately, with a bunch of different priorities we have as an early stage company, it's not in the product yet, but we do have that data. We do have that partnership. They've been awesome to work with, and that will soon hopefully be in the product. On top of these claims that we send back to you, Christian will show you in the demo, we do have some add-on synthesis, summarization, and evidence classification features. We were lucky enough to get early access to GPT-4 through our relationship with the OpenAI team. But, in the ethos of a lot of what everyone else has said, we try to really constrain those summaries just to the results on the page, so it's grounded in reality and it's not black boxed. Excited to show you here in a second. Christian and I's background is not in academia. We are technologists. We come from families of academics, but our background is really in building tech products. So that's really the way we want our product to feel. We try to listen to our users, many of whom are students, and that is what the roadmap dictates. It's going to be a lot of features that come from the asks of our users and university partners. So who is Consensus for? As I kind of mentioned, we wanted to build this product because we felt like it was extremely difficult for people like ourselves who wanted to engage with research but had no formal background in doing so to actually feel like research was approachable and accessible. So we wanted to build it for people like ourselves. So put simply, Consensus is designed to make research more approachable and intuitive for novices. We have a really wide range of users using the product. We've always thought if we serve that more novice audience, we could always also be a tool in the toolbox for more hardened researchers. That has basically exactly been the case. We have tons and tons of undergrads using the product, but we do also have PhD researchers using the product. And kind of when we talk to them, it really is exactly that. People who are more hardened researchers are using this tool as a starting point to surface research. But again, there are plenty of awesome other AI tools that are specifically designed for specific parts of the research workflow. And that's not exactly what we're trying to do. To give you an idea of where we're at as a company, we launched only about 5 months ago. In that time, we have over 125,000 registered users who have created accounts and executed searches. All of that growth is from what you see on the right, just word of mouth sharing. We spent $0 on marketing. It is just people popping open Twitter or other social media accounts saying how cool they think the product is, and it's growing via that way. We have users from over 1,000 unique global universities and over 250 high schools. Also have a few middle schools using the product, which is really, really cool, which speaks to us in solving this problem for a more novice audience. Today, the product is free, but we are rolling out an individual premium tier later this year, hopefully at the beginning of the summer. And then we'll also have a dedicated organizational tier, hopefully for the fall of 2023. And then I included this stat in the bottom. This is from a 4-year study by Carol Peruso on if you don't have any interventions in teaching undergrad students, what resources do they typically use? She found that about 70% of undergrad students begin their research with a Google search. And that really speaks to the problem that we're trying to solve. If people are going to Google to begin their search, we want to be that on-ramp to actually making research feel more intuitive, approachable, and accessible. I'll toss it over to Christian,
Awesome.
My co-founder, for a demo.
Awesome. Let's jump right into a demo. So yeah, like we've been saying, we really focused on making the product experience approachable, accessible for anyone. So kind of in line with that, we have all kinds of different example questions to try to coach our users and students how they should format a question to get good results in consensus. So I'll just click one of these here to show you what some of the results look like. Can zinc help treat depression? So like Eric mentioned, the results in our product are our claims. We rethought the academic search engine experience, not only as a search for papers. We obviously have the papers and people can access those, but we really thought about it as the search for answers. So we extract through a custom trained AI model, these word for word claims from research papers. And then we actually perform a search over these potential answers to your question. And then for specific types of questions, I can click this synthesize button up top, and then you see where some of the real magic happens here. So on the left, we have our summary feature, which is powered by GPT-4. But instead of just asking GPT-4 for the answer or a summary to be produced out of the ether with no citations and no true search results, we really constrain it and try to make sure that, it's not this black box answer. This summary is generated over the top 10 most relevant research papers that we can find in consensus. And then on the right side, we have what we call the consensus meter to show you, is there a consensus for your question? Now, right now, it only triggers for yes or no questions so that we can classify the results into yes, possibly, or no. But yeah, this is a way that students, researchers, anyone at all can kind of see a snapshot of the research if there's agreement or disagreement for a particular question. If I want to learn more about a paper that one of these answers comes from, I can click into the details page. There's a link to the full text at the Semantic Scholar website, and I can read more information from the abstract that the answer comes from. Some other useful workflows and use cases, especially for students, would be we have a lot of students use these claims to add quotes to papers that they're writing. So I can just come in here, I can click copy text, instantly have the word for word answer from the paper that I can embed in something I'm writing. I can even include the link with the text. And in the future, we're going to have much more, many more citation exporting type features here to support that. Last thing to cover in terms of features would be we have these really cool, what we call quality indicator tags. So not only are we trying to make the research easier and more accessible for students and for novices, but we're also trying to help coach people what is important to look for when assessing the research. So we have a partnership with SciScore, which is an awesome organization that rates journals by how rigorous their standards for submission are. That's one way that we assess the quality. We also have this really cool machine learning model that reads through the paper and predicts the type of study that these answers come from. So this one is from a randomized control trial. We try to highlight to users that this is, a really well designed study. And we'd love to work with universities, with libraries, with researchers to add more of these quality indicators to help coach our users what is reliable research. Really quickly, before I wrap it up, just to show, I have a little problem here. Live demo. Just to show that we have a diversity of types of subjects that you can ask. It's not just, the medical sciences. You can do questions on economics. You can do questions on social policy. And our machine learning models are fairly accurate for all of these types of questions. Again, this is coming from the Semantic Scholar database. So we have a lot of different domains that students can use to ask questions. Anything I missed there?
No, I think that's great. And then, I guess one last thing, the consensus meter, you can see what feeds it. All of the results that go into it have the tags that map to how they're classified up there. And again, just speaking to the ethos of trying to get some of this power of these generative models, but constraining it, keeping guardrails on it, and using within like a more holistic product experience. But I think that's great.
Thanks, guys. Appreciate the presentation, and between the three of us and the rest of the audience, go Cats, right?
Okay.
And next up, we will head down to Charlottesville, Virginia, and talk to Dustin Smith from Hum. Good morning, Dustin.
Good morning. We're not going to share like that. We're going to share like this. So I'm Dustin Smith. I'm co-founder and president of Hum. We're a customer data platform for scholarly publisher, and we have AI at our core, which is why we're here today. I'll tell you a little bit about that. But one of the key insights that we had a few years ago was there was a phenomenal amount of uncaptured behavioral data that comes from all of the user content interactions on publisher properties. And this is a great potential strategic advantage for publishers. This is data that they have that nobody else has. And what Hum does is Hum structures that data into profiles. So we can understand users, who they are, what they like, what they're interested in, and all the way to very deep behavioral insights on the depth that they're actually engaging with particular pieces of content, particular topics. And we're able to do that for not just people who are logged in or identified, we're able to do that for anonymous audiences as well. So you're able to understand that anonymous audience, a huge publisher problem. And we take that behavioral data and we're able to combine it with all of the other data sources that a publisher has, the sort of classic identity, demographic, and transactional data to really paint a universal view of people, content, topics, and organizations and how they actually interact with publisher properties. And so that's classic customer data platform sort of stuff. We capture more types of objects, but we've sort of flipped a CDP on its head. And so ultimately for us, a CDP is how we get this structured data into the LLM space. And for us, we have a proprietary modified version of an open source LLM, which sits at the core of Hum. And ultimately, we're feeding all people, all content, all behaviors into that language space, into that LLM. And so for us, that becomes a general sort of computer, which we're then able to fine tune for downstream tasks like personalization, recommendation, and insights. And this gives a deep, very, very deep understanding of that people, content, objects, and all the behaviors. So we can ultimately reach into that LLM space and provide insights for things like content and topics who are bringing in new people or creating lots of engagement. We can look at cohorts of people whose interests change dramatically over time and where they're traveling in that language space. You can link all of this to particular products, ultimately seeing as they're growing to some sort of tipping point, certainly looking at people with narrow interests versus omnivores. And all of this gives you an ability to ultimately manage your business better as a publisher. And CDPs are about more than just generating insights like you might get with a sort of data lake and BI dashboard approach. It's really about how do you put that data in play. And so there are many potential uses that you can put Hum to work at. I'm going to highlight just one today and happy to follow up on others. But this is really about how you create a data asset and how you ultimately put it to work. So we're going to talk about reviewer recruitment. And we're going to talk about a particular case with a Hum customer. Rockefeller University Press is a very small publisher, but using Hum to great effect right now. And so for what they did is they wanted to go, they wanted to build their list for people in membrane and lipid biology. And so this is a particular area in which they wanted to actually firm up. And so they built a segment of people who had demonstrated recent interest. And one of the things that this approach gives you is you are reaching into that language space, into the space of what your audience is doing and reaching particular people. So people in your audience, not just people in a cold database. And so what they were able to find was roughly 10,000 people who had high engagement, high recent engagement with topics surrounding lipids and membranes, the place in which they're actually looking to build out their list. And they refined that list further. They wanted to exclude all of the people who were existing reviewers. They had a few other conditions. And what Hum allows them to do is basically build those segments of people based on all the data that's contained within Hum, reach into that large language model and pull out the people that they ultimately want to reach out and engage with. And so the CDP is basically feeding that structured data in the front of the LLM and also pulling it out and using it for downstream tasks. So one of those is actually on-site, reaching out to people who were in this segment of roughly 3,800 people who were interested in membrane and lipid biology. And so what they did is they put up a pop-up modal that asked those people, the relevant sort of people who had recent demonstrated interest, would they consider reviewing on the topic of membrane and lipid biology? And ultimately, they had 87 people who put up their hand and said, yes, I want to do that. So this is ultimately creating a data asset which can be leveraged by an LLM, downstream task of ultimately activating off that data for a really critical business use case where ultimately you have an exhausted list of reviewers, you have 90 reviewers that come in the door over a 50-day period. So trying to give everybody a little time back, but that's how I'm happy to talk a little bit more about that later.
All righty. We are back and we will have our final panelist, Kalev from, where are we here? Are we there, Kalev? There we are. Kalev, who you might remember, spoke as a keynote speaker in the Galliard Center at the Charleston conference a few years ago. He is joining us from Arlington, Virginia, and he's going to talk about the GDELT project. Kalev?
Thank you so much. It's an honor to be here today. So the idea of the GDELT project is really this idea of how do we use massive computing power to essentially catalog and understand the world around us, and specifically taking news media from across the entire planet And synthesizing that from, you think about news is written for humans. It's designed for humans to consume, whether that's text, whether that's imagery, still imagery, whether that's audio, whether that's moving imagery. Across all those modalities, it's designed for humans. So how do we use machines to look across the entire planet, to try to understand, catalog the events, the narratives, the emotions, our global dreams and fears? Today, we monitor over 400 languages, with over 100 languages that we translate. Now, I won't get into that today, but there's actually, as you hear about all these new large language models that increasingly have multilingual capabilities, unfortunately, despite their size, despite their impressive capabilities on long tail languages and even mainstream languages that are just outside the sort of upper core is really no better than the embedding models that we had 5 years ago, and they're no better even than the models that we had 10 years ago. And this is a huge challenge. ChatGPT's performance on Burmese, for example, in our work is no better than models that we had our hands on 10 years ago. And that's a huge area we're working a lot in. And I have a whole series on that. Again, I only have 7 minutes today, so I can cover a lot of ground really fast. But again, over 400 languages. And actually a big part of this is even detecting the language that you're looking at. Whole bunch of things. So today it's used everything from sending out one of the very first alerts of COVID actually came from our data, 10 p.m. Eastern time, December 30th, 2023. We detected an extreme anomaly, SARS-like viral pneumonia of unknown origin. That was then used to send out a worldwide alert by Blue Dot Global up in Canada. Today it's used to track global events and risk, global events and narratives all across the world. In fact, actually much of the world's global risk work actually is powered by GDELT today. Even things like looking at global happiness through the news media, being able to track things in real time, the emotional undercurrents of the world. And using it as AI has gotten better and better and better and better, using it to try to understand the world around us, building graphs of the narrative landscape of the world's news across languages. What are the first glimmers of tomorrow's stories amongst the deluge? And how are the world's people, places, and things interconnected? And what can we learn from that as we represent the news as these immense graphs? What are the fundamentally new types of insights that emerge from that? And who drives those global conversations? Not just what is out there, but who are the driving factors behind all of that? We can even do things like fact check television in real time, scanning it for known fact checks second by second, and flagging this, providing context around that. And most recently, using things like large language models like ChatGPT and Bard and others to summarize and explore the news. Now, I'm not going to focus on hallucination and attention limitation today. If you're interested, look on our blog. We have a huge series on this. Unfortunately, hallucination is actually getting worse with each model update. So ChatGPT, the current iteration, I think the March 14th iteration, is actually much, much worse at hallucination than it was even 30 days ago. It's getting progressively worse. Recently we did a demo. We asked ChatGPT to summarize an ABC evening news broadcast about the Chinese spy balloon. We ran it 6 times in a row. Once it completely ignored anything to do with it, but 5 of those 6 times it hallucinated everything from it was a nuclear weapon to the Chinese detonated a nuclear bomb and obliterated the American homeland to ballistic missiles, you name it. And the reason that there's 6 of them is we ran it again and again and again and again, and we just couldn't get it to back away from those hallucinations. We could not, in 6 runs, we could not actually get it to give us a version that actually summarized it coherently, and that's a huge challenge. And of course, attentions and things like Whisper, which is now becoming a big thing. So generative speech recognition, that's a huge area. We've got an entire series on hallucination there. And so this is something to keep in mind, is you'll see a lot of people kind of hand wavy, talk about hallucination, or say, well, it's kind of an issue, it's kind of not. At least when it comes to news media, it is a catastrophic issue, and is one of the reasons that we continue to use large language models in experiments and not deploy them in production. Is at least in the category of global news media, we cannot get them to not hallucinate, and unfortunately, the current confidence metrics that come from these are not sufficient to exclude those. Now, of course, one of our more recent collaborations with the Internet Archive around television news, more than 5.2 million broadcasts from 100 channels from 50 countries on 5 continents and 35 languages, spanning portion of the last 20 years. So we have, for those that are closed captioned, we've had captioning keyword going back 10 years. We OCR the on-screen text of that in about 300 languages. We can use that on-screen OCR, do things like identify on-screen text, connect the digital and the broadcast worlds. But the Ukraine invasion really emphasized we need more than search. We need to really be able to skim television news. So we went through a huge project about how do you make television news skimmable? I mean, television's linear. How do you make that skimmable? And so we have a huge initiative around that. You can look at all of our work on that. Ultimately, we came up with every 4 seconds, we extract one frame, we make it a thumbnail grid. You can click on any of these and play a brief clip about it. For Belarusian, Iranian, Russian, and Ukrainian, we transcribe, we use speech to text and then translation on that. About 1.1 billion words available. So you can pull up any of these broadcasts. You can see them. For example, here's an Iranian broadcast. We can pull it up in Persian or in English, Russian, Belarusian, Ukrainian. So you can basically see the broadcast here and basically see the overdub. And again, machine is not perfect, but it's good enough for people, especially our volunteer armies, to be able to see stuff and say, wow, look at that. And then be able to toss it over the fence to someone who can then confirm and say, yep, that's absolutely correct. You can do all kinds of things. We are doing a lot of work with large language models. So here is summarizing Iranian broadcasts, describe the people, places, and things in it. Even more interesting things. What's the opinion towards the US in this broadcast? Make a table that goes with this. But of course, with television news, the big thing is the visual dimension of that. So we're doing a lot of interesting work on object detection, translation. We can ask it, what's different about television in the COVID world than pre-COVID? So bookcases, of course, come out. We can do provenance. So we can take every frame and we can run an open web search do essentially a reverse Google images search across the open web for any instance of that image and actually restore provenance, even the broadcast. And this is a huge area when we talk about combating deep fakes or falsehoods. Provenance is everything. Even the Pope in a puffer jacket. If you were able to take that jacket, if you were able to take that image, walk that back to its first appearance in the open web and say, oh, it appeared in a fashion section of this Reddit blog. That's huge. Being able to visually search television news. So we're doing things like OpenAI's clip. You can actually do things like soldier in front of a Russian flag. Being able to do visual clustering. So take a clip, a video clip, and track that over a year of television news to see every occurrence of it and how it's being used. Look at things like thematic analysis. So military imagery, tracking that on Russian television. This is an interesting example. Tucker Carlson appears all over Russian television. We're able to take his face and say, track this across Russian television. We're able to actually see and count up the exact number of seconds. More interestingly, we can take an episode of a 2.5-hour broadcast. 60 Minutes is a very famous Russian broadcast. Take all the faces and then look at who appears next to whom on television. So we can actually make a network and show it revolves in the center. You can see Olga, she's sort of the main person there. You can see how it revolves. We can then scale up to an entire year of television and really see who and what it's circulating around. And then finally, for those that are scared about the future, it's really frightening. We asked it, take an Iranian news broadcast, watch the entire broadcast, identify any mentions of the nuclear deal that are critical of the nuclear deal, then come up with a highly persuasive Twitter thread, LinkedIn post, Telegram post, and news op-ed in English and Persian, written the voice and perspective in Iranian, targeted Iranians, and come up with corresponding imagery to illustrate those. Absolutely frightening, and really shows that, that what our future is, what entails our future. Now, again, these are not creative. What it writes is not creative at all. But when compared to what human folks come up with from the State Department and others, it beats them by a landslide. And so again, shows us that, yeah, AI is not that creative, but compared to the humans that are doing kind of this rote work, it's really spooky. Thank you so much. Everything I presented is open data, all of it available today, and just a fraction of the work that we're doing. Thank you so much.
Wow. Thank you, Kalev. Incredible presentation, as the same goes for all the other ones. We've got limited amount of time, a limited amount of time and a lot of questions. So I'll start with one and we'll go back and forth. Lee and I will start with one and try to get at least one for each of our presenters. And by the way, I would encourage, if the question's not for you or your company, feel free to jump in with your thoughts on whatever the question might be. Well, I'll start with Kalev. Kalev, I know there's a difference between GDELT and GDELT summary. Can you talk a little bit about the differences? Because I know there are some people here who are familiar and can work with APIs while other people cannot.
Yeah, so GDELT, essentially, it's at the highest level, it's a massive initiative to understand global news media. We have all these downloadable data sets that are, I think, 8.5 trillion data points and climbing very rapidly. We have APIs. So GDELT summary is essentially like Google News. It's a web interface. You can keyword search our machine translations of online news. You can keyword search the captioning, OCR material, and other analyses of television in collaboration with the Internet Archive's TV News Archive. And so GDELT summaries, essentially, it's the one that's most heavily used by journalists and scholars that are non-technical people. And it also have APIs wrapped around that. And then we have all these downloadable data sets. And on our blog, because everything we do is open, on our blog, all these code samples are available there. So you can go right in there. If you understand R, we've got R samples. If you want a Python notebook, it's there. If you want Python, Perl, C, etc. We have demos across everything. Go to the blog, find it, replicate that code. And that's really the idea, is to really push the boundaries of what's possible today. And again, showcase what we can do with all these data.
Thanks. Leah, do you have a question ready to go, or should I continue?
Yeah, so I've got one that was repeated a couple of times for Juan with Writefull. Earlier yesterday, one of our panelists said that any chance to detect ChatGPT submissions is doomed to fail. What is your opinion on the long-term success rate of plagiarism detection?
I basically agree. I think in long term, it's going to be very, very difficult to detect. We've done a lot of experiments with our models. So we have custom models to detect outputs from ChatGPT, GPT-3.5, and GPT-4. And with GPT-4, it's already quite difficult to detect in some instances if it's actually coming from GPT-4. So long term, I think it's going to be difficult. So how I see this is that it's good to detect it now while we adapt policies to know how we're going to deal with this in the future.
Great,
The question for Artur and Laser.ai. Does Laser.ai demonstrate how the systematic review process undertaken is replicable for future researchers?
Yeah, so this is really how I interpret the word systematic, that it's replicable, that you can basically apply the same criteria and get the same result, which, by the way, is not always true. We have research on that. But to kind of document how the process went, we generate a number of reports, including, for example, the Prisma flowchart. But yes, in general, we try to leave as much of, let's say, transparency, give as much transparency as possible.
Thanks. Leah?
Sure. So a lot of varieties of this question for the consensus team about, well, my thing just scrolled, rigorous journal. How do you define rigorous journal? Where do you get the citation data from? So there's some questions around that, the source of your data there.
Yeah, I just added a little blurb on that to one of the questions in the Q&A. But yeah, we partner with an awesome organization called SciScore. I think they're out in San Diego. And what they've done is the largest scale analysis of scientific methods of all time, analyzing the methods of millions of articles, or classifying which of the articles use studies that met specific rigorous scientific criteria, like blinding, randomizing,
Diversity of population.
yeah, diversity of population, diversity of gender, all kind, appropriate statistical power, many criteria that someone would say, hey, this is a rigorous experiment. And then they rated journals by how often papers in that journal met those criteria. So it's definitely like a proxy metric for us, but we thought that it was much cooler than just a traditional, bibliometric like impact factor measure of a journal that is only about citations. This is actually getting at some of the methods. But yeah, check out, I think it's sciscore.com. Awesome organization we get the data from.
And it's
Dustin, a question.
in certain percentiles is when we add the tags. So in the top 10%, we apply a very rigorous. In the top 50%, we apply a rigorous. And then in the tooltip, it's linked to SciScore and gives a little blurb of what goes into it.
Dustin, for you, a question. When selling user data, how do you ensure that demographic data like student immigration status does not end up in the hands of law enforcement like ICE? How can people opt out of all this personal data capturing?
Well, for one, I did answer this in the question. We never, ever, ever, ever sell data. We create a specific instance for each customer. We're the data processor, they're the data controller under GDPR, and we work only with consented data. So ultimately, if you reject cookies, we are not capturing data on you. So ultimately, you have to agree basically to operate under the consent framework that the publisher has set up. So this is how you build ethical relationships with your users. And we would obviously strongly suggest our publisher customers do not sell their data on to other parties, and particularly don't participate with folks like ICE. So,
thank you for clarifying that. A question that I saw here that I think is very interesting, and I'd like everybody to comment on, not only for your company, but just as experts in AI and machine learning. Are you seeing attempts to game AI like we've seen with search engine optimization or SEO? Anybody want to jump in on that one? Or is that, or look at it another way. If you're not, is this something that we should be on the lookout for?
I mean, I think a lot of at least from my perspective in the news world, I think a lot of that's going to come from, it has to be deployed somewhere first so people know how, how to game it. Right now, obviously with Bing now deploying it, I think you're going to, you are going to see now this increase. Now you have a specific tool to target. It's sort of like with SEO gaming, you had to game Google differently than you had to game some of the others. And I think, as there's sort of a consensus on, different tools being standardized in different places, I think you will to a certain degree, as we understand, like LangChain that a lot of folks are using has specific artifacts in how it chunks text and feeds it into, say, ChatGPT to overcome the very limited token limitations. But even that, so that we see like in news content, the chunking you use has immense impacts on ChatGPT's ability to process the text. You can send it wildly off course by the tiniest change in how it gets chunked, simply because of a lot of limitations. But already now, there have been announcements of large language model tools that have an order of magnitude larger attention capabilities. A lot of those are not publicly accessible yet, but as those come online, that will go away. So I think, again, it'll be an arms race. But yeah, it'll be very interesting once there's kind of consensus of what tools to target there.
Anybody else have a comment?
Yeah, I think it's going to be really interesting in the near future, now that these tools are being connected to the outside world more. That's when there's actually going to be more of an attempt to potentially game them. Like to date, when ChatGPT is released, it's a very self-contained thing within its own little box, which means the only gaming you really see is people trying to like break it to take a screenshot and then send it out on Twitter. But now that with plugins coming and like just mentioned, the Bing chat that is actually connected to the outside world, where it'll be referencing articles and buying products and booking trips, I think that is where you'll see like a similar type of equivalent with the SEO hacking, where there are going to be people who try to optimize their content to be able to be searched by AI and clicked on by AI. Exactly how that works, I'm by no means an expert to say that, but I think the more these get connected to the outside world and aren't in their self-contained boxes, the more we'll start to see that kind of equivalent. And that's coming soon.
Peter, I know you answered this in the chat, but I like everybody to make sure to hear it. When is Core GPT coming? And how can people be ready for it? Can they sign up to be on a waiting list, that kind of thing?
Yeah, it's a very good question. So at the moment, like we keep Core GPT private for people who are really interested in. So if someone wants to obviously write us, then we might be able to give you access if this is not too public. The challenge for us at the moment is not technical. The challenge for us is purely organizational and financial, basically. So we're at the moment trying to figure out a way how we could make Core GPT available for a larger group of people. If I may, I just wanted to go a little bit on the previous question. I think what is really interesting is that I think we really need to wait and see a little bit. We need to analyze what's going to happen to ChatGPT is somehow still quite new. We need to better understand how it's working and in which context it can be it can really serve us well, and in which context it's really dangerous. I'm a researcher at the university. At this university, everyone is really worried about this from the perspective that students will use it to generate essays, which they are already doing. Then there's a question of, like, can we detect it? And then there's a question of, can we actually feedback? Can we provide feedback to students also using ChatGPT? And then it becomes somehow sort of circular. And I believe that after some time, we will find ways how to make sure that ChatGPT doesn't sort of overcome the world and that it becomes a good slave to us rather than something that drives us and does everything for us. So that's for me.
And going on that, actually, if people are interested in exploring for themselves, again, because GDELT is all open data, and because we oftentimes work with a lot of sort of the frontier AI groups, a lot of our blog focuses on these specific issues. This is a huge issue for us, is what are the limitations? Not just, again, in the commercial world, you see a lot of the splashy, OpenAI putting out these demos of, look, this is amazing, it's great. And like Whisper, you saw a whole companies adopt that immediately as a production tool. Versus a lot of our focus is on what is the reality here. And I will say the guardrails play a huge role, and those guardrails are constantly changing. Like with OpenAI, we actually have been able to document how those guardrails have evolved in just our processing of news media. Because again, when you're looking at news media across the world, even mainstream outlets in other parts of the world are not what here in the United States we would consider to be healthy conversations. And so we trigger those guardrails routinely, and and what we can see is, well, you change a few words and you can hop around that guardrail. So we already see to some degree around the world kind of this reaction in a way. I don't think it's purposeful, but you have certainly seen that as not large language models, but more limited tools, the moderation tools have leveraged bits and pieces of this. You have seen a reaction across the world. So you're already starting to see that as elements of these make their way into those large language models for, even things like clip for image filtering. You already see that gaming there.
One more question. I think we have time, Leah, for one more.
I think so, yeah.
I really like this question. And I know one person has answered in the chat, in the Q&A, but let me ask it to everybody. Should we always be encouraging researchers, especially early career researchers, to use AI apps, work quickly, and save time in their research workflows?
Yeah, so I answered this one in the chat, and I'm happy to repeat my answer here. So I think that doing this work is a very, I would say, good opportunity for education. And this is something that we hear from our users, that they used to ask the students to do at least one systematic review as part of the curriculum to really familiarize themselves with the process and also with the domain very often. So I hope that some of this remains, although in the same way we have factories and we have artisans, right? So maybe that will be really the direction.
Anybody else want to?
I would encourage it. I mean, at least, as a researcher myself, former academic who has a long string of papers that, like one of my early Twitter papers found 3% of tweets are geotagged. Today, I will see academic papers every day citing 90%, 100%, 50%, every wild number citing it back to my paper, because somebody does a Google search, they find some number, they kind of conflate it with my paper and they jump it in there. And so I'll say that, we think of, well, these machines, they make mistakes, they're not great, it's better for humans to do it. Well, I'll say, at least from the standards of my own personal experience of people citing my own papers, the quality of academic citations is so catastrophic now, even in tier 1 journals now, that I would say if AI could help with some of that, at least make sure that this citation is actually from this paper and is the real number, I would encourage that. Because again, we're saying, well, AI is here and this is an idealized world of what humans are capable of, instead of this is AI and here's what the real life academic world is like, and the actual quality of how people cite.
I would encourage it as well. I think it makes sense to allow basically this, because also if you don't encourage it, what's going to happen? People will use it anyway, basically. So there isn't an option basically of preventing people from using it. But I think there are definitely areas where we need to be very careful. One thing that worries really me specifically is that I feel that critical judgment will be more and more important. People will need to be able to judge and really look at everything that is served to them with a critical perspective. And I'm not so sure at the moment that our students, researchers and actually the society is able to read stuff in those ways, and therefore I feel our society is really prone to sort of misinformation and these kinds of things, and we need to fight that. And I think that fight can be won, but it requires a lot of attention.
I think what Petr said is really well said. I'd also like to add that I think the more that it's encouraged and used, the better these tools will be able to be developed alongside researchers and academics and students to then actually meet their needs. If it's just pushed away, there's no feedback, there's no collaboration, there's no way to actually build the tools that eventually will make everybody more efficient in what they do and cut out parts of the process that could be better served with a tool to help them do it. So iteratively designing and taking in feedback is the best way to design tools that actually meet people's needs, and by encouraging the usage of it is the best way to do that.
All right, well, it's 11:15 and it's time to move on. So I'll turn it back over to Leah. Thank you, everybody, for participating in today's panel, in today's presentations and discussion.
Yes, thank you, everyone. It was a fantastic panel, learned a lot. We're going to move over to breakout groups now. So I'm going to put the link in the chat. It's also provided on the virtual event page, the link that was in your confirmation email. You can select day 2 breakout groups. Give us a few minutes. You'll be in the waiting room when you first join. I'll pop over there and we'll get the breakout room set up and start our discussion time. Thank you very much, everyone. I'll see you over in the breakout rooms. Bye.